Welcome, students. Today's lesson is called Factoring Quadratic Equations when they're in the form of x squared plus bx plus c equals 0, or without the 0, as you'll see to begin with. This is x squared plus 17x plus 42. Now these are trinomials that we are going to factor into two binomials. So right away you know you're going to have two sets of parentheses. Now when you go to factor these, you're going to pay attention to your first and your last term to begin with. X squared means there will be an x in each binomial because x times x makes x squared. Now look at your last number, your 42. In this situation, we know that the last two numbers in our binomial multiply to get 42. So we have to think about what factors does 42 have that will also add to get 17, your middle number. So when you're working with your C, your last number, the two factors you write down have to also add to be 17, since everything is positive in this trinomial. So when we think about our factors of 42, 6 times 7 is the first one that comes to my mind. And if you add those, you get 13, not 17. So let's think 2 and 21. Again, if we add those, we don't get 17. Let's try it again. Let's try 3. 3 and what do we get? 14. And if we add 3 and 14, we get 17. So that's where our two factors will be, are 3 and 14. And since everything's positive, everything in here will be positive, and there we're finished. Just kind of trial and error to find your factors that will add to get your middle number. And that would be 3 and 14. And it doesn't matter if 14 goes first or 3 goes first. The order of the binomials doesn't matter. Okay, on the next one, we're going to have two binomials. The c comes first with your x squared term at the end, and that's fine. Just flip it around if you want, or just know that it's going to end with the t. They're both positive, so everything will be positive inside here. And then this is our number. The 9 is on the first. Whatever factors of 9 have to also add to make 10. So obviously 3 and 3 won't work, but 9 and 1 will. So 9 and 1 will be our two factors. And there's our two binomials, and we're finished. There's your answer. Let's do it again. Now in this situation, they're not both positive. So we're going to think about this for a second. Start with our two binomials. We know we're going to have a w in each one. This time, the two factors to get our c are positive 28, but they have to yield a negative number in the middle, a negative b. So when you have two numbers that that multiply to get a positive, but will add to be a negative, they have to both be negative factors. So we have to think what times itself is 28, but added will be 11. And of course 4 and 7. That makes sense. But in order for them to add and stay negative, they have to both be negative. So will two negatives make a positive, but also add to be negative? And yes, they will. So that's why these two binomials are negatives. Let's try this again. Same situation. We've got an m in each one. We're going to have a positive c, but a negative b. So they're both going to be negative. And then we need two factors for 50 that will add to get 15. 5 and 10 jump out at me, and that's it. So 5 and 10. 5 times 10 is 50, and then 5 plus 10 is 15. And they'll both be negative. Let's do it again. This time the variable's at the end, and we know that it's going to be a positive variable. So both our variables will be positive, but our numbers will both have to be negative. So we can put a negative in here right away. All right, two numbers that multiply to get 21, but add to be a negative 22. That'd be 21 and 1. So it's a negative 21 plus m and a negative 1 plus m. Okay, let's go do another example. Now we're going to have our c negative and our b negative. So this one's when you got to slow down a little bit on these and think about it for a second. It's going to start with r in each one. Since both are negative, this time the two factors that make 24 will have to subtract to get a 2. So let's think about what our factors are first. 6 and 4 subtract to get 2, so it's going to be 6 and 4. So we know 6 and a 4. And we know one's got to be positive and one's got to be negative in order to get a negative 24. But which one's negative? That's when you look at your middle term. It's a negative 2, so that means when you subtracted them, the bigger number was negative. So the 6 is negative and our 4 is positive. And there's your answer. So always look at that middle term when you get to that point. Now here's another one. We're going to have an a in each one. We've got two factors that multiply to get 48, but subtract to get 8. And 4 and 12 jump out at me because they will subtract to get 8. So we know we're going to have a 4 and a 12. But this time, and one's got to be positive, one's got to be negative in order to get a negative 48. But when you subtract them, the final answer is a positive. So that means our bigger number is positive this time, and the 4 is negative. Let's try again. I have a y in each one. This time a 48. Our two factors will have to subtract to be 13. And we know it's not 4 and 12 because they subtract to get 8. So let's go bigger. Let's try, what's 2? 2 and 24, that won't work either. 3 and 19, 3 and 16 rather, I'm sorry. 3 times 16 is 48, and then if you subtract them, you get 13. So we know we've got a 3 and a 16, and once we subtract, it'll stay positive, so our biggest number is positive again. Let's go one more time. Factor these out, we'll have an n and an n. We know that two numbers have to multiply to get 35, but subtract to get 2. And 7 and 5, that one's really easy. We're going to have a 7 and a 5. But when we subtract them, it'll be a negative answer. So our bigger number out of the two will be a negative. The other one will be positive. And remember, you can always check these. Go back and do FOIL and see if you get that answer. And so this would be n squared. If we go backwards, it would be n squared, negative 7n, a positive 5n, and then a negative 35. And we put these two together for a negative 2n with a negative 35 and n squared. And that does match, so we know we're right. And this is a check. You can always check them. If there's one that doesn't feel right, check it. Doesn't mean you have to check all of them. But you certainly can check them. You're also going to have to solve the equations when the trinomial is set equal to 0. And you're just going to start out like we've been doing. Factor first. And this is all equal to 0. We'll have an x in each one. We've got a negative 18. So this means you'll have a positive and a negative. Two numbers that multiply to get 18. This means I'll have to subtract to get 3. 6 and 3 make 18. So we'll have a 6 and a 3. But when you subtract them, the bigger number is positive because of the middle term here. So that makes our 6 positive and our 3 negative. And that is very important. If you made the 3 positive and the 6 negative, you'd have this completely wrong. Once you have it factored, you're going to set each binomial equal to 0. So you'll have x plus 6 equals 0, and you'll have x minus 3 equals 0. Then you solve it. The answer here is x equals negative 6, because we bring the 6 over by subtracting it, and we'll bring the 3 over by adding it, so it's x is positive 3. So those are your two solutions. X is negative 6 or x is 3. Come over here and do this one, but it doesn't say equals 0, so you have to make it say equals 0. So we'll rewrite it, z squared minus 3z minus 70 equals 0. Bring the 70 over. Now we can factor it. All equals 0. We'll have our z's in each one. We've got a negative 70, so again, they'll be multiplied and subtracting to get 3. So two numbers go into 70, 7 and 10. So put 7 and 10 down. We'll have the biggest, since our middle term's negative, the bigger number will be negative, smaller number positive. And we'll set them each of these binomials equal to 0. Z plus 7 equals 0, and z minus 10 equals 0. And we'll subtract our 7 away. So z could be a negative 7, or z can be a positive 10. Those are your two solutions. About out of time, but I'm going to do two more of these really fast. Two binomials equal to 0. You have x in each one. This time you've got a negative middle term but a positive, so they're both going to be a negative. And they'll add to get 15. So 9 and 6. And there you go. You factored it. Now you'll set them each equal to 0. X minus 9 equals 0. X minus 6 equals 0. And that means our two solutions would be a positive 9 and a positive 6. There we go. One more for those of you that need one more example. C in each term. This time they're both positive, so we know they're both positive here. 9 and 1, because 9 plus 1 makes 10. This one's really simple. C plus 9 equals 0. C plus 1 equals 0. Means our two solutions are C is negative 9 or C is negative 1. And that's it, guys. I'll see you in class.